Jai Gurudev. Good morning, student. Today we'll start standard state. First of all, understood standard state is given by the superscript like that. That 0, if to standard state, you write that 0, and then you have to draw a horizontal line like that. So this is your standard state. Standard enthalpy of reaction is del R H standard. Standard enthalpy is the change in enthalpy during a reaction. Now, del R H standard is equal to sum of the enthalpies of the product minus reactant. So, enthalpy of reaction is the standard enthalpy of reaction is the change in enthalpy during a reaction, and in mathematically given del R H standard equal to sum of the enthalpies of the product minus sum of the enthalpies of the reactant. Now, next definition is our standard enthalpy of fusion. So it is given like that del fusion H standard. So it is the enthalpy change when 1 mole of a substance melts. Similarly, standard enthalpy of vaporization is there. So it is the enthalpy change when 1 mole of a substance converts from its liquid state to vapor state. Enthalpy of sublimation is there. When a 1 mole of a substance directly changes from the solid to vapor state, this is enthalpy of sublimation. The enthalpy of vaporization designated by del Vap H standard, del sublimation H standard is enthalpy of sublimation. Now, standard enthalpy of combustion. So it is the enthalpy change when 1 mole of a substance is burned. 1 mole means if 12 gram of carbon you burn in oxygen, you are producing carbon dioxide. The 1 mole for burning 1 mole means 12 gram of carbon. How much enthalpy change during that reaction? This is enthalpy of combustion, del C H standard. So enthalpy of formation. Next one is enthalpy of formation. So it is the enthalpy change when 1 mole of a substance is formed. For example, if you want to prepare 1 mole of C6H6, we require 6 carbon solid plus how many hydrogen? 3H2 gaseous. Similarly, if you want to prepare your glucose, it is C6H12O6. You require 6 carbon in the solid form, then hydrogen, 6 hydrogen, 6H2 means 12 hydrogen in the gaseous form, and we require oxygen. So we require 3O2 in the gaseous form. So all these things gives us enthalpy of formation of glucose. So you remember you have to prepare 1 mole. So this is what is called enthalpy of formation. Next, we are doing one important law. This is Hess's law. According to this, the enthalpy change during a reaction, if a reaction is done in one step, this is reactant to product. If you done in one step, then del R H enthalpy of the reaction. If you done same reaction in the several step, so this is del 1H, this is del 2H, this is del 3H. So if a reaction done in one single step or it is done in several steps, then the net enthalpy during a reaction in one step is equal to the sum of the enthalpies of the several steps. So this law tells that when a reaction takes place in one step, or it takes place in one step, you are doing this one, or it takes number of steps. For example, if it takes number of steps to come to the product, then the sum of the enthalpies of these is equal to the whatever the enthalpy of the first step. So that part you remember. Then enthalpy of sublimation. Enthalpy of sublimation it is the enthalpy change. Then enthalpy change when one mole of a substance directly convert from solid state to gaseous state. Then we have standard enthalpy of solution. Standard enthalpy of solution. So actually standard enthalpy of solution is equal to the sum of the lattice enthalpy plus hydration enthalpy. Now, when a substance, for example, if I take NaCl, Na positive and Cl negative, if you take that one in water, first of all, your Cl and Na will be separate. To separate the Cl and Na, we require to give an energy. This is your lattice enthalpy. Now after that Na and Cl separated, Na will form bonding with water molecules. Na will form bonding with water molecules. So and Cl also forming bonding with water molecules. For that the energy release is your hydration enthalpy. So your lattice enthalpy and hydration enthalpy combinedly form what is called enthalpy of solution. The one point student remember, for a substance to be soluble in water, the lattice enthalpy must be low and hydration enthalpy must be high. If a substance wants to soluble in water, its lattice enthalpy must be low and hydration enthalpy must be high. So that is what you require to know.